Okay, hello everyone. So in this video, I'm going to be reviewing concepts of ambiguity. So what does it mean for context-free grammar, or for grammar, sorry, in general, to be ambiguous? Because we haven't covered that yet in the tutorials. We haven't covered a lot of things yet in the tutorials. So I'm trying to fix that little by little, video by video. So this video, like I just said, is going to be about ambiguity. So this is just a quick recall of the definition of ambiguity. So this is in the context of grammars, right? So um, an ambiguous grammar is essentially when there are at least uh, two distinct ways. Let me put a big asterisk on what distinct ways is. I have to talk about that in a second. But there are two distinct ways of deriving a string W in the language generated by the grammar, right? So this is like relatively intuitive. If a grammar can generate a string in at least two distinct ways, then we say that the grammar is ambiguous because you don't know, given the grammar and the string, you don't know which one it's going to choose. You don't know which derivation rules the grammar is going to choose to um, get to W. So there's some ambiguity there, right? Um, and so the reason why there's an asterisk on distinct ways is that it's really important. So it's important um, that the ways of deriving W are truly distinct. So it can't just be um, you um, it can't just be some sort of artificially distinct way of generating the string in two different ways. It has to be like a meaningful difference. Okay. So what does that really mean? Meaningful difference? Like for example, if I give you the following grammar, so consider the following grammar G, very simple grammar. I have the start variable S, which gives me AB, then I have A, gives me A, and B gives me B. Then L of G is actually just finite, right? The only string that can be generated by G is AB, right? Um, and now someone could say, well, there's two distinct ways of generating AB, right? So I can say S gives you AB, and then A can be replaced by A, and then B can be replaced by B, right? So that's one way. And then there's a second way where S gets replaced by, well, S again is AB, but now I decide to replace B by B, and then A by A. Okay. And so I say, well, this is ambiguous because there's two distinct ways of deriving the string AB. But um, the 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 problem here is that we're not using the same um, ways of deriving the strings in both cases, right? So, um, like if I say um, there are um, there are many different ways of deriving um, a string just because I'm sort of um, arbitrarily choosing what production rule to use at any given moment. Like the fact that you're doing something arbitrary, that there's no sort of consistency in the way you're choosing the production rules, that tells me that the ambiguity doesn't actually come from the fact that there are actually two distinct and two like different ways of generating the string, but rather it's just like me fiddling around with what production rule to use. So the so that was a bit of rambling. The more I think convincing thing is, if you consider the parse tree, of this grammar G for the string AB, then the parse tree for both of these derivations actually looks the same, right? It's S gives you AB, and then A gives you A, and B gives you B. So what this has done is if you sort of ignore the order of replacement of a given production rule, then uh, your derivation is not actually ambiguous, right? So what we care about is we care about meaningful differences, right? So if it was something like S gives you A, and then that gives you B, C, and then this gives you A, and this gives you B, then that's meaningfully different, right? Because maybe there's one particular meaning given to the variable A and B here, and then there's one other particular meaning given to the variable C here, right? So these two parse trees look different, and it's sort of the parse trees um, that sort of determine whether a derivation is meaningfully distinct from another, okay? So um, in case you didn't understand anything of that, I don't really blame you. Really just what I wanted to say is for G to be ambiguous, there must exist some string in L of G such that there are at least two distinct, and then actually there's a few options that you can check. So either there's two distinct leftmost derivations. So leftmost derivations are where you decide, like the convention is production rules, you replace the leftmost variable all the time. So then if there are actually two distinct derivations, then you're sort of following always the same convention, but at some point you diverged, right? Um, and so that's meaningfully different. So the same thing for rightmost, where the definition is very similar, right? You just keep replacing the rightmost variable, or like we just said, right? So these are ors. Or like we just said, you have two distinct parse trees. Okay. In fact, the or is actually not, I mean, it's true, like logically speaking, but it turns out that leftmost derivations have like a one-to-one corresponding rightmost derivation has a one-to-one corresponding parse tree, right? So like all these ways of deriving strings are um, equivalent in that you can sort of take a leftmost derivation and there's a unique parse tree that corresponds to it and vice versa, right? So in fact, like one, if and only if two, if and only if three, because there's sort of a one-to-one mapping between their structures. Okay. So that's what we mean by like meaningfully different. It had to be like you're using some set convention of deriving a string, and if using that set convention there actually is like an ambiguity at some point, then that means that the grammar is truly ambiguous. So what's an example of this? Well, let's actually consider the grammar that we looked at a video ago. So if we consider this grammar. The question that I can ask you, which you can, feel free to pause the video and ponder about it for a bit. Um, but the question is, is this, if this is G, is G an ambiguous grammar, right? That is the question. Okay, so the hint here that it probably is an ambiguous grammar is I can almost immediately see two different ways of generating ABA, right? So you can use AS, so then the A is going to be at the left. Then you can use BA, so then you're going to have ABA and then A, and then you can finish. Or you can just directly generate ABA on the left, right? Um, so you can do, so the answer is yes, it definitely is. This is one of the reasons, but actually there's a few others. So S could be derived, S, you could replace this with AS, and then you could replace this with B, A, and then A, and then this A could be replaced by epsilon, and then the yield of the parse tree would be, the yield would be AVA epsilon, which is just AVA. Or you could use a different parse tree where you have something like A, B, A, and then A can be derived, or A can be replaced with epsilon. And then here, this yield is also the same, right? So the yield of this parse tree, which is just like what happens if you read off the leaves, where all the leaves are supposed to be terminals, or the empty string, then you get the same yield, right? So you have the same yield, meaning that you have um, two, so you have two distinct parse trees for the same generated string, right? The yield being ABA means that the string generated by the grammar is ABA. Um, and the parse trees are distinct, and so by this definition, that means that G is indeed ambiguous. So yes, because of there are two distinct parse trees for ABA. Okay, and so the question which I will answer in the next video is, okay, so I know that this grammar is ambiguous, but as an additional question, is the language that it generates, right? So now this is a question about the language. Is L of G inherently ambiguous, right? Meaning that, um, is it true that for any grammar that generates this language, you're going to have at some point some kind of ambiguity for at least one string, right? So is there, um, so in other words, um, if the answer is no, then you should be able to find a grammar where there are no strings that their derivation is ambiguous. If the answer is yes, then that means that for every grammar that generates the language, then for every grammar that generates the language, then there should be at least two sort of ambiguous derivations for the same string, right? Two distinct derivations for the same string. Okay, so I'm gonna stop here and let you think about this, and then I'm gonna solve it in the next video.